Hi everyone, welcome to this video tutorial. Today we're going to be talking about the OSI model. The OSI model is a standard way of understanding how devices communicate across a network. Network communications are very complicated, involving a lot of different technologies and protocols. The OSI model breaks up this process into 7 manageable layers, each layer being responsible for a particular function of the communication process. In this video, we're going to look at the journey of data from one device to another across a network. Okay? And we're going to use that to try and explain each layer of the OSI model. So let's get started. So we've got an application, for example, a web browser, and we want to communicate with another device, for example, a web server. So we start on the application layer. The purpose of the application layer is to initialize network services for the application. So we've got a web browser here, which needs to communicate with a web server. The application layer will initialize the HTTP or HTTPS protocol. If our device is an email server, then the application layer will initialize the SMTP protocol to allow the email transmission to happen. Okay, so that's the purpose of the application layer. Once that's done, we move down to the presentation layer. The purpose of the presentation layer is to take our data that we want to transmit, compress it, encrypt it, and possibly format it so that the receiving device can understand the data. So really, the purpose of the presentation layer is to prepare the data for transmission by compressing it, encrypting it, and potentially formatting it as well. Once that's complete, we move down to the session layer. The session layer basically sets up a communication link between the two devices. And it does this by handshaking. Handshaking means the sending device sends a synchronizing signal to the receiving device. The receiving device gets that synchronizing signal, acknowledges it, and also sends its own synchronizing signal. Okay, so that's what's being represented here. Once the sending device receives that synchronizing signal, it just sends one final acknowledging device to say, hey, you've got my synchronizing signal, I've got your synchronizing signal, we're synchronized, we're ready to go. Okay, and the communication link is established. That's the purpose of the session layer. Once that's complete, we move down to the transport layer. The transport layer uses a protocol such as TCP to break the data that we're going to send into small chunks. On the transport layer, these chunks are called segments. Now, if we're using TCP, each segment will contain a chunk of data that we want to send and some kind of order number. So this is segment number 1, this is segment number 2, and this is segment number 3. Now, the reason the segments are given order numbers is that when they are sent across the network, all of the segments will take different paths, and they will arrive at the destination device in the wrong order, probably. So at the destination device, we will go back up to the transport layer, and TCP will reorder the segments into the correct order. TCP will also request the retransmission of any segment that didn't arrive. So if segment 1 arrives, segment 3 arrives, but segment 2 doesn't arrive, TCP will make sure that a retransmission request is sent. So TCP really ensures the reliable transmission of data. There is another popular protocol which is used on the transport layer. It's called UDP. And UDP guarantees fast transmission, but it doesn't ensure that data arrives in order, and it doesn't request retransmission of any missing data, right? So UDP is commonly used for things that need to be done quickly, such as video streaming. Whereas if you're sending an email, you really want to use the TCP protocol on the transport layer. Once the segments have been generated on the transport layer, we go down to the network layer. The network layer says, hey, segment, where are you going? And of course, the segments want to go to the IP address of the receiving device. So the network layer, using the IP protocol, will take a packet and it will take a segment and include it in a packet along with the IP address of the sending device and the IP address of the receiving device. Those three things will be encapsulated in a packet: the segment, the IP address of the sending device, and the IP address of the receiving device. Okay? Once the packets have been generated using the IP protocol on the network layer, we move down to the data link layer. Now, in this kind of transmission, each packet is going to visit different devices as it continues its journey across the network. For example, one of these devices is probably going to be a router. Okay? So in order to facilitate transmission, we need to know the MAC address of the next router on the path to the destination. Okay? So on the data link layer, we take a packet, we include the MAC address of the next device that will receive the information, and we include that in a frame, right? So a frame includes a packet and the MAC address of the next device to be visited on the journey to the destination. On each hop, the frame is removed or deconstructed, and a new frame is constructed with the packet. The packet doesn't change, it's still the same, and the MAC address of the next device to be visited on the journey to the destination device. Okay? And that continues until the destination device is reached. So that's the purpose of the data link layer, to produce frames. Then we reach the physical layer. The physical layer takes each frame, transforms it into a stream of bits, and then these bits are transmitted across the network. They could be transmitted as electrical signals, for example on an Ethernet cable, or light pulses if we're using optical fiber, or radio waves if we're using wireless technology. Okay? So that's how the OSI model works. Notice that at the receiving end, when a frame arrives at the receiving end, it arrives as a stream of bits. So we start at the physical layer on the receiving end. Then we go up to the data link layer to reconstruct those bits as a frame. Then we go up to the network layer to get the packet. Then we go up to the transport layer to get the segments. And eventually we'll go up to the presentation layer to get the original data or information. And then whatever application is using that information here on the receiving device will be able to use that data. Okay. Now, in modern network communication, we're really thinking mostly about the internet. Okay. So for the internet, another model has been designed. It's called the TCP/IP model, okay? And it kind of simplifies the OSI model a little bit. This is what it does. Let me just see if I can draw some squares here. The TCP/IP model takes these three layers, application, presentation, and session, and it says, okay, you guys, I'm just going to call you the application layer. Okay. And the transport layer and the network layer remain the same. So let's just make that clear. This layer here is still called transport. And this layer here, well, it is the network layer, but because we're specifically dealing with the internet, they renamed it the internet layer. Okay, but it has the same role as the network layer, the generation of packets. Okay, and then the final two layers here have also been merged, and they are called together, they're called the link layer. So the TCP/IP model kind of reduces the OSI model. It's the same, but instead of having 7 layers, you've got 4 layers. Okay? And the application layer in the TCP/IP model takes care of the application, presentation, and session layers, which are in the OSI model. Okay? It does everything but within its own layer. Okay? And that is a very brief introduction to the OSI model.